Hello, welcome back to Mrs. Tor's YouTube channel. Today, we are going to talk about vertex form of a quadratic equation. So, the past few days, we've been looking at graphing quadratic equations, and we've been looking at them in this form. This is called standard form. Over here, this is vertex form. So, it's y equals a times x minus h squared plus k. So we still have that squared term. If we were to FOIL this out, we would still get the x squared that we have in standard form. So it's still a quadratic. In vertex form, A represents two things. The first thing that it represents is if your parabola opens up or down. If your A is positive, your parabola is going to open up. If it's negative, your parabola is going to open down. And it also represents the vertical stretch or shrink. So, if the absolute value of A is less than 1, so let's say A is negative 1/2, 3/4, something like that, it's going to stretch your graph. So our parabola is going to be a little fatter. If the absolute value of A is greater than 1, so 1, negative 2.5, things like that, it's going to shrink your graph. So it's going to be kind of skinnier. In vertex form, our vertex is going to be the opposite of H, so the opposite of this number here, and then K. So what we're going to do is when our equations are in vertex form, we can very easily pull that vertex out, graph it, and then we're going to use symmetry. All right, let's look at an example so you know what I mean. So here's my example. Y equals x plus 1 squared minus 3. So let's kind of think about what our graph is going to look like, what our parabola is going to look like. Well, our A is 1, right? So it's positive, so that means my parabola is going to open up. And 1 is kind of the standard shrink or stretch, right? It's not going to really shrink at all. It's not going to stretch at all. It's just going to look like a normal parabola. So let's find the vertex. The vertex is the opposite of this number, so that's going to be negative 1. And then this number, negative 3. Well, let's graph it. So negative 1, negative 3. And then, what's our axis of symmetry? That's going to be x equals negative 1. Let's draw that in. All right, so this is what I mean by using symmetry. So what we're going to do is we're going to choose a point that's close to the axis of symmetry. So our axis of symmetry is at negative 1. We're going to choose an x that's somewhat close to it. So let's say we choose 1. So x equals 1. That's really only 2 spaces away. I would say 3 spaces away from your axis of symmetry is kind of the max that you want to go. You want to stick close. Because the further that you get away from your axis of symmetry, the further up your y-axis. So a point that's like at x equals 7 is going to be like way up here. So it's going to go off your graph. So try to stay close to your axis of symmetry. So what did I say? I think we're going to use 1. So when x equals 1, how do we figure out what our y value is? We plug it in, right? Y equals 1 plus 1 squared minus 3. You can just type it in your calculator, or you can do the math. 1 plus 1 is 2. 2 squared is 4. 4 minus 3, that gives us 1. So that means 1 is a point on our graph. So now we have one side of our parabola. We know it's going to go up like this. Now here's how we use symmetry. We look at our point and say, how many spaces away from my axis of symmetry am I? Well, I go 1 to 0, 0 to negative 1. So I'm 2 spaces away. That means if I go 2 spaces in the other direction, That means 1, 2, negative 3, 1 is also a point on my graph. Once I have 2 points, I go ahead and graph my parabola. And that's what it looks like. That's all vertex form is. All right, let's look at another example. All right, so y equals negative 2 times x minus 1 squared plus 4. So let's think about what our graph's going to look like. Well, our a is negative, so our parabola is going to turn down. And then the absolute value of negative 2 is positive 2, so that shrinks our graph. So our parabola is going to be down facing, and it's going to be a little skinnier than normal. All right, so let's identify our vertex. 1, negative 4, because it's the opposite of this number, and then this number. So let's graph it. 1, 2, 3, and 4. And then our axis of symmetry is going to be x equals 1. So let's draw that in. All right, now we can just choose a point we choose an x, I should say, that's close to our axis of symmetry. Well, my axis of symmetry is 1. Let's say we choose 3. So when x equals 3, what's my y value? Plug it in and find out. Negative 2 times 3 minus 1 squared plus 4. Again, you can just type it all in your calculator, or we can do the math. So we'll get negative 2 times 3 minus 1 is 2. 2 squared is 4 plus 4. So that's going to be negative 8 plus 4. That's going to give us negative 4. So that means 3, negative 4 is a point on our graph. Let's graph it. Wait, something happened here. -3, so -3, -4. Oh, my vertex is positive. Oops. Positive 4. That'll make a difference. 1, 1, 2, 3. There we go. All right, so now we can graph 3, negative 4. So 1, 2, 3, and then down to negative 4. All right, now we use symmetry. So we are 2 spots away from my axis of symmetry. So if I go 2 more, 1, 2, I'm going to be at negative 1, 4, or negative 1, negative 4. Once we have our 3 points, go ahead and graph it. All right, that is it for vertex form. Next lesson, we're going to go from standard form to vertex form.